Hello, here I am again. I thought I'll continue my process. I fixed the stuff I was having troubles with in the past session, and I'm doing a quick session now where I want to add some motion to the flame. Let me run you through what I did here. I implemented a use input here for, well, let me show it in the scripts. Use input toggle or hold. In case of toggling, I can flick the switch to turn the flame on and off, and you'll hold the thumbstick or the button on your Vive controller for the flame to be lit and release it again. I had a lot of logic issues with, other than what happened in the past session, I also had logic issues with invoking teleport while holding a flaming lighter. It's beautiful stuff. It's only in development work that you get problems like that. But it seems to behave now. Let me just first show how it works. Let me see. Everything should just hold up. Here we are. One lighter, two hands. I simply pressed it, thumbstick, and the flame gets created. I release the thumbstick and it gets puffed out. Works in my other hand as well. I can now have it lit, and I should be able to also teleport. So good. I think I missed the trick. So I have it lit. Nope. Okay, there's still some issues. Sorry. I think I can have it in my left hand and then teleport. That's no problem. I can't have it in my right hand and then teleport. Well, I can't teleport, but I can't have it lit and then teleport. That's funny. So I have it lit. So there's still a little logic issue. And I teleport when I release the button. But it works reliably enough now. So let me head back. I'm not gonna try and fix this logic issue. I will look at that later. It's not much of a problem. I should probably handle all the inputs, all the teleport inputs, and the flicking of switches when holding items a bit differently. But hey, so and now I will run through the logic I created, and I will want to have some motion on it when it moves back and forth. So let me get to that. So shall I go through the code now? Let me see if this is interesting. I sped it up like this. There's now an event here on positive input and on negative input that works nicely with the hold or toggle bits. So in case of hold, the negative input is releasing the button. In case of toggle, the negative and positive inputs are switched around depending on the current state, internal state of the flame, well, of the input system here. Just, yeah, it's mostly logic stuff. Let me not bore you with that. Let's get to the motion of the flame. So this is the animator of the flame. Well, this is the controller. And this is the animator. Let me just start adding what I thought up. I think I want to have a capsule collider on this one. Make it tiny. And I'm using a capsule collider like this, I guess. Not for the collision, but because every let's do that at 0.045, because every rigid body has to have a volume it can work with to decide which way to work. So I'm just adding this, make this into a rigid body. Use gravity, that's okay. I will set this as a trigger so it won't actually collide with stuff. If I do nothing now, it will just fall down. So I want to use another. Oh, let me put it over here. Reset it so it's at the same location. Hey, why can't I double click on this word? Okay, tablet problems. Okay, I should just hover. Flame attachment point. I usually try and keep, because I'm gonna connect this to this with a joint. This will be a rigid body as well, but fully kinematic, and we'll have a configurable joint here that will attach to the attachment point. Motion is locked. Angular motion I'm gonna keep at 3 for now. I'm gonna slurp it a tiny little bit, just because in my experience it's good to have a bit of slurp on my slurp spring on my joints. So there we are. Wow, it's translating into Dutch here, which is weird. Very weird. Didn't see that before. This should already work. I have now attached the capsule collider here, but I won't be able to see what happens. Maybe if I start with an ignited version. Oh, crap. Yeah, crap. Don't do that. Maximize and play off. Let's see what happens. If I press play here. Nothing. Cool. Interesting. It's already a bit in motion. Can I ignite it here? Yeah. And can I move this one about? Not convincingly, but because it's parented to the big LiDAR object here, it probably will just keep rotating with it. This is something we might want to have to counter. Let me see what happens if I just rotate this. nothing. Okay, if I rotate the attachment point, nothing happens, so we can't counter that. Just a bit of a puzzle, physics puzzle here. I really want to contain everything, including the flame, inside the LiDAR object and have it move with it, but be dragged behind it. Now you would imagine that you can do that with drag here, but I promise you that won't. Well, I promise it would be nice if it worked, but it probably won't. No. Drag just dampens the overall physical effect of the rigid body. Oh, enable drag on the LiDAR. I should enable drag on the frame if I want to try this. So let's see. Yes, play. See, no drag. And that's because I'm rotating this object, which has as childs the dynamic object here, and the attachment points and all. So it just moves with it until it gets a jolt from the outside, which it won't get. So, let me think. I think the easiest way to do it would be to add another null here. Sorry, an empty game object. Small flame platform. And this game object I will keep at every physical update. I will keep upright, and yeah, that should work. And we're gonna child this to this. So if I rotate, let me have a think. That won't work. Nope. Okay. Thinking silence again. That won't work. Okay. What you usually want to do to have dynamic objects move about is to keep them separated from the objects that they should follow. Let me try and see if I can make this work without breaking my scripts. So here's the flame. Let me ignite it. Now if I move the lighter, that's funny. Maybe don't use this then. Just puzzling. Maybe if I use this as another trigger. Now we're getting somewhere, yeah. But this looks bad. Very, very bad. Okay. Still puzzling. Small flame is attached to this. Let me see if I can just do something simple in the small flame controller. We're already open. And that's like what I think we want to do is add a force to it that's countering the velocity of this object here. But I'm not sure if this object is getting proper velocities, if it's kinematic. So let's just try it out. So okay, let's first add a parameter here. Public float counter motion is like 0.5, just to add force against the velocity. We will need for this, we will need the rigid body attachment point, which we can just find. We will need a rigid body RBD. That's my go-to what's the word for short word? Fighting for words again. I always use this RBD to refer to the own rigid body. So get used to it, I would say. BD is get component in. No, just get component rigid body. The attachment point is get configurable joint. I'm now illegally hard coding the structure of my object in here, but we're just prototyping. Attach it. Wait a minute. What's it called? Connected body. Connected body. There we go. That should solve that. So we now need a fixed update. Void fixed update because that runs in simulation time and not in regular frame rate time. What I thought I could do was RBD at false and then use attachment point velocity times minus counter motion, and yeah, that should be okay with normal force. Let's check. No, thank you. Let's check what this does. Nope. So that won't work. There's no force being applied. Okay, maybe just use its own velocity then. Yeah. Compiling. Don't see anything happening. That's too bad. Thought I had a simple solution here. What if we track the velocity by hand? Let's put last position here. Start. Last position is equal to transformed in position. Okay. Velocity is transformed in position minus last position. Care time dot delta time. Well, I think this velocity should be divided by time, because it's just a distance over time. This should be good. Then we should do last position equals transform current position, and that should track the velocity here. So will this work? Why doesn't this work? Maybe because the force isn't applied at force at position. At relative force, maybe? No. Because this force is of course applied at the how do you say that? At the center of gravity of the object. Let's use this, but that's just in here. Be the center of mass. Center of mass is equal to, let's just hard code some stupid fellow in here right now. Let's put a measure probing empty in here because we're scaling here as well. So I guess the center of mass could be about here. Maybe just call this center of gravity. I always call it center of gravity. This one is upwards like 0.05 units. Vector 3.up times 0.05 float. Will this work? Yeah, done compiling. This is funny. Seems, it's got a mass maybe. No, it's got a mass, but it's using gravity. It shouldn't be using gravity. That would mean why won't you just work, man? If I drag this thing around, it should just get dragged behind itself, right? I don't get it. Drag an attachment point around. Don't see this thing lagging behind at all. Precision spring is still at something, maybe that's the problem. No, it's not the problem. I don't get it. Configurable joint, attachment point, how to configure is good. Motion is locked. Angular motion is free. There's no slurping going on. Well, position spring is at 0. Why is this always turning out to be more difficult than expected? I hate it. I think I'm overlooking something here. Let's put that mass at 0. This here. Counter motion 0. Maybe. I just messed it up a bit. How can it be that when I drag this point about, that the flame here doesn't get dragged about? It's just small flame here. I knew this was a bad idea. It's late here. I thought, let me just fix up that motion just a bit. But of course it won't work. How about when I do use this might be something. Let's use not a trigger, so it will bump up a bit because of collisions. Now it seems to look like it's behaving more like you would expect. Yeah, okay. It's just okay, gotcha. So that's the problem. I'm doing all sorts of stupid things for naught. Okay, let's leave that over there. Problem is that if you give the rigid body volume by giving it a capsule collider, but if you keep it as a trigger, then it simply won't work. So you need to use a actual collider here, but because you don't want that collider to collide with anything, you're gonna have to use your layers. And I don't think I have a good layer for no collision. Yeah, so there's my new layer. I will go to the physics and disable collisions of this thing all over the place. This won't collide with anything now. No collisions. Yes, that's good. I believe it's invisible. Yeah. Let's make it visible. Now, let's see if we need a counter motion. Let's put that on 0. We just start our experiments again from the start. Lighter. Oh. Okay. Once more. We don't want to use gravity here. We do want to ignite the thing as soon as we're starting up. Boom. Yes. What happens if I move this about now? Nope, that won't work. If I move this about, see? This works now. And that's because I don't move the parent here, but I move the attachment points and leave this one to be trailed behind. So now we're gonna see if we can counter the motion with this force here. Probably not. Nope. That's a bit weird because oh, let's see, a center of mass. That's okay. Add force. Add force at position. I'm not sure if this position is a local position or a global position. I think it's a global position, so that would be RBD dot center, world center of mass, right? This works a bit. So I'm now just applying force counter to the motion. Let me check, because I'm gonna redo everything now that I did here. Let me check if I could do this also with attachment point dot velocity. Doubt that that will work. Oh, an error. Attachment point dot velocity. What's the problem here? Name last position does not exist. Oh, I have that also in start here. If this doesn't work, I need to remember to fix that all back up again. So, go. Oh, joy, joy, joy. You're right. I thought so. One extra experiment, so let's not use its velocity, but just use its own velocity. Maybe that will work. Just saving out a few lines of code if it does. Nope. Nope. Because both the attachment point and the small flame are moving with the lidar. They don't track any kind of velocity, it seems. So we'll have to manually track the velocity like this. Velocity, and I'll put it here at 0. I'm gonna move these two up. Tracking the velocity equals the RBDs. I call them RBDs, I'm so sorry. Move with the lighter in this case. Okay. This is a hard-coded value. Let me think. It doesn't really matter, as long as it's a bit above the y-axis in the flame. That should be good. Now, I think I want to overdo this a little. Let's put it at 8, see what happens. Come on. There we go. Might be nice. Now you can see what the slurp drive, because I probably put that back here. Let's call that like so. Okay, the default values were fine. I actually think now. Since this lidar here is a rigid body as well, I don't think we need this at all. We can just attach the small frame to lighter itself. We will also remove this because we are not using it anymore. Yes. And funny thing now is oh, hello, can I please get my yes, thank you. Is that if we turn the lighter into a non-kinematic object, it will fall to the floor. With the flame, it doesn't fall to the floor because it doesn't use gravity. But there we go. And we can just up it about. And we'll still have to do something about the fact that the flame is sticking out of the lighter at this angle. Let's do that. It's just a matter of also adding a force. RBD add force. I think this can be normal force being vector 3 dot up times, well, let's just use something close to gravity for now. Let's make anti-gravity. Let's go like that. Public flows anti-gravity equals 9. There will always be an upward force of hello? Ooh. Oh, that's right. The upward force. It will try to keep the lighter afloat. That's a bit silly. It should just be very, very tiny. Dot 1 maybe. And it should actually be a lot stronger. Anti-gravity 0.1. That's 0.1, I guess. It should probably be a lot stronger than, well, not a lot stronger, but this is countering it a bit much now. Let's see what happens, like so. Okay. I don't really like the damping, the lack of damping here. That can be just heavy. Oh. Ooh. Okay. Okay, the rest is just tweaking these values. Dot 1 and 0. There we go. I want some, but 2, no, 0, and dot 01. Dot 01. Just the only thing this position spring here does is try to keep the flame sticking out of, well, this way, so to say, in the y-axis of the lighter. This is making it a bit sad and slow. That's not nice. I think that's mostly a lack of damping, maybe. Dot 05. Tweaky, tweaky. Twiggy, twiggy. I think these values are okay now. Let's remember .01, .05, and let's have gravity 2, maybe 0.3. Oh, sorry. The only problem with having any anti-gravity is that it will pull on not only the flame but also the lighter itself, which is a bit weird. Okay, we'll leave it at this now. .03 here. .01, .05. Oh, that's 3, sorry. 3. .01, .05, and I'm gonna play around with it in VR. See what happens. I may have broken something by turning it on. Yeah, see, because the I use a force on the flame now to keep it upright against gravity. It kind of drags the whole thing around, and it probably will fall. Oh yeah, I'm still having it set on kinematic. It will probably fall slower as well, thanks to that. So we really should apply a torque instead of a force. But I like where it's heading, and you know, it's just a silly lighter. So maybe this is maybe this is good enough for now. Because the tweaking is what takes the most work, and the logic, of course. Okay, let me fix the gravity on that. Oh, you probably didn't really see what I was doing there in the small screen here. Sorry. Let's see. The thing that's missing here is that I want to enable kinematic on detach. I don't want to enable kinematic on detach, so let's turn that off. Turn this off, and let's see what happens if I play around with it now. Well, what do you know? It fell down. Very good. Oh, see? Okay. Well, we're prototyping here, so who cares? Who cares? I know how to fix this some other time. Right now, we have a functioning lighter. Well, yeah, look at that. Woohoo! It actually feels really good, I should say. Okay, that's my teleporting bug. It's a bit messy. I end up on my chair here. Oh well. Getting turned around. So, this feels really good. This feels flamey and nicely and slow. So, maybe I'll keep it in. I'll just have to make sure that when I turn it off, things get turned off. Because, well, this is a bit silly, right? Such fun. Cool. Well, that was step 3. I like what I'm seeing here, but I think I'm gonna use in another session. I'm gonna translate this force I'm applying right now, which is just a vector going upwards. I'm gonna apply a torque to the thing when it's pointing sideways and not when it's pointing upwards. And I don't think a torque will pull on the rest of the lighter where a force will. So there we go. Take care not to drop it while teleporting. Oh yeah, I also want to fix this thing. When I keep the flame lit and I release it, I get teleporting immediately. Oh well. So, again, thanks for the audience, and see you when I finish this off. Bye bye. Okay, hello. A tiny little addendum, because I fixed the problem of the floaty lighter here. I suddenly remembered while editing the video that there's that there's this setting now in your configurable joints, connected mass scale, and that defines how much the forces on this object, so on the flame, will influence the motion of the rest of the dynamic object, so in this case the lighter. So I set that to a tiny little bit. I fixed also some things in the code, just little small silly errors. I used a fixed delta, used time delta time here, and now use a fixed delta time here. Maybe some other things. Let me quickly show you how it works now, and then we can sign off. Oh, I really still... I have it on kinematic for testing purposes, but as soon as I pick it up, it gets dynamic again. So, still working fine. Maybe you can already see that the motion of the lighter is a bit different here. But when I release it, no more silly floaty business. So there you go. Fixed. Wonderful lighter. Oh, and it lands straight on its face because it can. Whew. There we go. So, hey. I think we have a working prototype here now. I can fix it up a little so that, for example, it goes out if you hold it like this, but I think this will be fine, and I should really only fix my teleporting issues, because when I'm pressing the button right now and I'm picking it up with this hand, I go into teleporting state, and there's more silliness like that. If I'm pressing the button and I'm releasing it, I get teleported if I don't watch it. I should fix that. Well, all done. See you in the next session.